Let's discuss question number 15 from test 2. This is from applied thermodynamics. So thermodynamics. The main advantage of reheat Rankine cycle is asked. Okay, so let's look at it. What is your Rankine cycle in a TS diagram? So you have these are your constant pressure lines, a higher pressure line, a lower pressure line, constant pressure. So you have basically a small pump which basically performs an isentropic compression, and then you just this is the point where water enters the boiler, and then the normal cycle would end somewhere here in the boiler, where the water is converted from saturated, the subcooled state to your superheated stream, and then in the turbine there will be a isentropic expansion. So at the end of the turbine you will have water, some part will be some dryness, some part will be as a liquid, and then in the condenser it will give out some heat and finally become the saturated liquid. So this is a 1 2 3 4. So this is what happens. But what is the problem is that at this point, at the exit of the turbine, in a ideal, in a normal Rankine cycle, this is normal Rankine cycle, exit of a turbine, you have both liquid plus vapor state. So what is observed is that this liquid, because if the dryness fraction is less than 1, so because of this liquid, it basically, it's not desirable, because this liquid droplets will try to, what is observed is that these liquid droplets will try to damage your blade surface, and that's why what is requested is that if the dryness fraction is 1, or if the exit is also in the saturated vapor or superheated zone, this state is more desirable from the performance of your, so what is observed is that what is done is that instead of here it is cooled, the turbine, you have two stages. Instead of expanding entire thing, it is expanded to some state, and then it is again heated, and then again expanded in another low pressure turbine. So you have two stages of turbine, and in between you have reheating. Okay, so you supply heat, it's heating, and then you expand in low pressure turbine, and this is where the output is. So now the output is basically the exit of the turbine, the state of the water will be superheated, so you avoid this damage to the blade surface and stuff like that. So reduce moisture content in lower pressure side of the turbine is what is the option. Okay, well, this increases the work done, and increased maximum temperature I would not say, because you can again reheat to the same temperature where it was at the exit of the boiler. So B is not the option. Reduce load on the condenser, well, it increases in fact, because condenser has to now start reducing the heat. This is the entry point of the condenser. It has to lose more heat, so that is also not the option. Reduce fuel consumption, no, it increases fuel consumption, because you need to supply some fuel to heat in this part. Okay, so B, C, D are not the option. A is the option, because moisture content is reduced. In fact, if you are in the superheated zone, moisture is in fact zero. You are completely in the vapor state. So that's why reheating is done. The advantage of reheating is it increases turbine work, but then it increases the heat added also. So efficiency cannot be said whether it increases or not increases. Main advantage is that work done has increased. Apart from that, this is the secondary advantage, that reduced moisture content. The dryness fraction is more at the exit of the timer. The quality of the steam is high. So option is A. Thank you.